Hi all, welcome back to one more lecture in statistics. In last lecture or last video, we have seen that what is a hypothesis testing, what are the procedure of or what are the steps that to be followed when we do a hypothesis testing. Then various concepts and terms associated with this hypothesis testing, like what is null and alternative hypothesis, what is type 1 or type 1 and type 2 errors, what is level of significance and power of a test, what is the tail of the test, then how to do a hypothesis testing for large sample, okay, then for small sample, then what we do when we know the population standard deviation and what we do when we don't know about the population standard deviations. Okay, then we discussed two different types of problem, one with z test or normal distribution and another one with t distribution, okay, or t test. Okay, so I'm giving a total idea about when to use z test and when to use t test. Okay, so look at this picture. If sample size is greater than 30, if the sample size is greater than 30, and whether you know the population standard deviation or doesn't know the population standard deviation doesn't matter, you have to go to the normal distributions. Okay, whereas if the population is less than 30 or equal to 30, or the sample is less than or equal to 30, but population is assumed to be normal. We don't know about the population, but we have certain information that population is normal, okay, or approximately normal. Then if you know the population standard deviation, then again you can go for normal distribution. But if you don't know, many times we don't know the population standard deviation, in such situation we can only go to the t distributions. Okay, so there are four different cases. First case is population n is great, sample is greater than 30, okay, and you know the population standard deviation, go for normal distribution. Okay, population is greater than 30, still you don't know the population standard deviation, still you can go for normal distributions. Okay, then the sample is less than 30 or equal to 30, but we know that the population may be, or population is assumed to be normal. Okay, then if you know the population standard deviation, again you can go for normal distribution. But in the case if you don't know the population standard deviation and the sample is greater than less than 30, but you are assuming that your population is normal distributed, then you can go for t test. Okay, so this is the situation when we have to go to t test or when we have to go to z test or normal distributions. Okay, I hope it is clear for you. Then this is a flow chart. This will tell you, this will give you more clarification when to use z test and when to use t test. Okay, so the first question is that, is the population is normal? Yes or no. We have two options. If the population is normal, yes or no. Okay, then if your answer is yes, then again there is one more question, whether population standard deviation is known or unknown. Okay, if it is known, yes, you can go to z test. If it is no, then you can go for t test. Okay, then the second question is the population is not normal. Okay, then one more question is there, whether your sample is greater than 30 or not. If your population standard deviation is greater, if your sample size is greater than 30, okay, still you can go for z test. Okay, Then if we know that if our sample is less than 30, then we have to rely on certain non-parametric test. Okay, so what are these non-parametric tests that we will see later. Okay, so this is just a flow chart how to select, okay, the t-test or z-test. Okay, so in last class we discussed how to do the hypothesis procedure when the population is large, okay, and when the population is small and we don't know about the population standard deviation, t-test. Okay, so we have used z-test and t-test, and we have done two different examples. Okay, and sometime we have to estimate whether the difference between two population mean is significant or not. We have two different population, then we have two different sample. Okay, so we have two populations. Okay, then by taking certain information from sample, whether we can infer about the populations, what we have to infer, whether there is a significant difference exist among these two different populations. Okay, so if we want to do such kind of analysis, still we can go with normal distribution and t-distributions. How? If two samples are normally distributed and we know the standard deviation, we can go for a z-test. The sample is less than 30 and we don't know about the population standard deviation, then we can go to t-test. Okay, so how we can do this? I'm not giving any example, but simply I am just giving some ideas. Okay, so let mu1 is the mean of first population, mu2 is the mean of second population. We have two population here. Okay, then what is the difference? Mu1 minus mu2. Okay, we have two population, then we will have two samples. Clear? Then the first average of the mean value of the first sample will be x bar 1 and mean value of the second sample will be x bar 2. Then what's the difference? X bar 1 minus x bar 2. Okay, so mu1 minus mu2 is the differences in the populations, the differences of mean difference of the population. X bar 1 minus x bar 2, it is the mean difference of the sample mean or samples. Okay, then we know that what will be the mean value, average value. We know that mu is always equal to mu x bar. We have learned that mu is always equal to mu x bar. Okay, similarly here what we can see, mu x bar minus x bar 2 will be always equal to mu 1 minus mu 2. This is what we call unbiasedness property. Okay, then but the standard deviation will be different. Okay, how we can find the standard deviation? You get the example, standard deviation of x bar 1 minus x bar 2 will be equal to population standard deviation or population variance divided by first total number of samples in the first sample, the total number of observations in the first sample plus population variance in the second sample divided by n2. Okay, it is n2 not n1. Okay, so it is population variance of the second sample divided by second total observation of the second sample. Okay, so it will be n1 n2 not n1 n1. Okay, there's a mistake. Similarly, we can find out sometime we don't know the population standard deviation, that time, or population variance we don't know, that time we can use sample variance. Okay, it is simply instead of population variance we are using sample variance, s1 square plus s2 square divided by n1 plus n2, both will be the same. Okay, yes, then now we got everything. Okay, so what will be the confidence interval here? Nothing, 1 minus alpha into 100% confidence interval for mu1 minus mu2. It will be x bar 1 minus x bar 2 plus or minus z into standard deviation. It's basically what? X bar plus or minus z into standard deviation. Okay, but here not mu difference. So x bar 1 minus x bar 2 plus or minus z value into standard deviation difference, x bar 1 minus x bar 2. Okay, or if we don't know the popular standard deviation, we can use z. Yes. Then what will be the z value? Z value is nothing but x bar minus mu divided by standard deviation. Okay, but here we are not taking the mean, but we are taking the mean difference. So what this will be x bar 1 minus x bar 2 minus mu 1 minus mu 2. Both are differences, average differences in the mean value of samples, minus population differences. Okay, mean value of the difference between populations divided by standard deviation of the difference between differences in the sample. Okay, if you know the sample, or if we don't know the sample, then we can use, if we know the sample, then if we know the population standard deviation, then we will use sigma, and if we don't know this, then we will use small s. Okay, yes. Then after this, we can follow the same 5-step procedure to continue with our hypothesis testing. Okay, the first step is null and alternate hypothesis. Specify the null and alternate hypothesis. There is no differences and there is differences. Okay, this would be our null hypothesis. Second one, what will be the distribution to use? Okay, this will be depends upon the normality assumptions and whether you know the population standard deviation or not, and how many samples you are collecting. Okay, on the base of this, it would be either z test or t test. Okay, then third one is we have to specify our rejection and non-rejection region. If it is z test, we have to go to normal distribution table, z table, or if it is in t test, then we have to use degrees of freedom and t distribution. We have to use the values from t distributions. Okay, but the finding out the values in both distributions are different. Okay, in z test we don't have the values of df, but in t test the values are depends on df. Okay, yes. The last one, find out the z value or t value just like this. Okay, then you reject or accept the null hypothesis. Okay, so this would be the procedure of testing whether the mean difference between two populations are significant or not. Okay, so we will follow the same 5-step procedure here in this situation also. Okay, yes. So in the last video, or in some classes before, or some I think I have discussed in this class. Okay, so what are the area, what are the purpose we can use t-test? The first one, hypothesis testing for the population mean, we discuss it. Second one, hypothesis testing for the difference between two population means in independent sample. Okay, we have two different independent sample. This means that we have two samples, but these two samples are entirely different. Okay, so that thing we have just discussed now. Okay, we have two population, mu1 mu2, then we have x bar 1 x bar 2. Okay, that is the independent samples. Okay, then the third one is hypothesis testing for the difference between two population means when the sample is dependent. When the sample is dependent. And we can also use this t-test for analyzing the correlation coefficient or significance of the correlation coefficients and regression coefficient, that we will discuss later. Okay, so now we have discussed first, second, and now we are moving to the third uses of t-test, that is hypothesis testing for checking the significant difference between two population means when the samples are dependent. Okay, or when the samples are paired or dependent. Clear? So for this purpose, we are using an exclusive t-test called paired t-test or matched t-test. Okay, so what is called a paired or matched samples? Okay, so two samples are said to be paired when for each data values collected from one sample and there is corresponding data value for the second sample, but both data are collected from the same source at different time period. What does it mean? We are having two samples selected at different time but from the same person or same entity. This is why we are calling it as dependent sample. Okay, for example, suppose we want to check, okay, whether the use of the pesticides will increase the productivity of a land. What we can do? Okay, we can do one thing. We can check, or you just take another example. Okay, suppose you are joined in a health club or a gymnasium. Okay, so you want to check whether your exercise in gymnasium has any effects on your body. Okay, so this is measured on the basis of your weight. So what you have to do, before we go into the gymnasium, we will measure our weight. Okay, then after certain exercise or after some period of time, 3 months, you take as 3 months, okay, we will examine what is the weight and you will just compare these things. Okay, so here we are collecting the sample from same person at different period of time before and after certain exercise. Okay, so in order to check this kind of a problem, we have to use paired t-test. Okay, then before we discuss this paired t-test, let me tell you, or let me give you some idea about what are the notation that we are going to use in this paired t-test. Okay, first one, mu d. Mu, we know that mu is mean, d is a difference. So what will be the mu d means? Mu d means paired difference of population. Paired difference of population. Okay, so what will be the standard deviation of d? Sigma d. It is the standard deviation of paired difference of the population. Okay, so earlier we had mu and standard deviation, but here we are having mu difference, then standard deviation difference. Okay, then what is the d bar? D bar is nothing but the mean of the paired difference for the samples. So average paired difference, that we call d bar. Okay, then yes, d bar, it is the standard deviation of the paired difference of the sample, or is the standard deviation of the paired difference of the sample. Okay, not SD bar, SD, small SD. Small SD means we are dealing with sample. Okay, small sigma SD, we are dealing with population standard deviation. Okay, that's the only difference. Okay, so how to find out small d bar? Nothing but sigma d divided by n, just an average. Okay, and how to find out the standard deviation of standard deviation? It is nothing but sigma d square minus sigma d whole square divided by n divided by n minus 1 under root. Okay, this would be the standard deviation of the sample. Clear? Yes. So we are just giving some concepts or some notations and its equations. Okay, now we are coming to a question, example. Okay, the table shows, there's a table, it shows that the blood pressure of 7 adults before and after the completion of a special dietary plan. Okay, so after 7 persons are going to have a dietary plan. Okay, so this dietary plan is aimed at to reduce the blood pressure. So a statistician want to check, or health statistician or biostatistician have to check whether this dietary plan has any effect on the blood pressure. How we can do that? Here the sample is dependent, because suppose if I am including in this dietary, if I am doing this dietary plans, so you have to check my blood pressures, not my wife or my brother. Okay, so here the sample will be the dependent, but after and before some exercise. Okay, so for the first adult, his weight was his blood pressure was 210 before, but after the exercise it has reduced to 193, and we are having data on 7 individuals. Okay, so here we have to find out first step, we have to find out what is D. Small d is nothing but the difference, pair difference. Okay, so in the first case 210 minus 193, the difference is 17. Okay, then the second case 180 was his blood pressure, but after the exercise his blood pressure has increased by 6. Okay, so the difference is minus 6. Okay, so we find out D. Okay, so in order to find out the standard deviation of the sample, we need to find out D square. Okay, so here we can also find out the D square. 17 square 283, 6 square minus 6 square is 36. Okay, now we find out what is D and D square is. Okay, then we want to find out D bar. What is D bar here? Average differences. Okay, so sigma D divided by n. You add all this 17 plus 19 plus 11 plus 16 minus 6 plus 3 minus 9. It will be 17 plus 9 plus 11 plus 16 minus 6 minus 3 and minus 9. So it will be, then there are the total number of observations is 7, so it will be around 5. Average differences is 5. Okay, then we can find out the standard deviation, and it will be 10.78. Okay, then standard deviation of X bar, here we are having standard deviation of D bar. Okay, it will be SD divided by root 10, it will be 4.07. Okay, so look at here we don't know about what would be the population standard deviations. Okay, and we know that the sample size is small. Okay, and we can assume that the population is assumed to be normal distributed. Okay, so in this case we can use the t-test to make the inference about this problem. Okay, yes, how to do that? First we can find out the confidence interval. Okay, we are having two things. First estimation will come, after that hypothesis testing will come. Okay, so how to find out the estimation? Estimation means nothing but find out the value, or assign the single value, or assign a value within an interval. Okay, the first case is point estimation, second case is interval estimation. Okay, so here earlier we are having X bar plus T into standard deviation of X bar. Okay, so here what we are having, D bar plus or minus T plus or minus, T into small standard deviation of D bar. Okay, so an area in each tail will be alpha by 2. Okay, so we have to assume 95% confidence interval, so area in each tail will be 0.25. Okay, and the difference and degrees of freedom is 7 minus 1 is equal to 6. Okay, so using this information we can refer to the t tables Okay, then we will get the value for t tables. Okay, so the value from t table is 2.447. This means that, okay, the average difference between blood pressure before and after the given dietary plan is between 4.98 and 14.98. Okay, so we will get this kind of a this kind of a two intervals. Okay, yes. So the next one, we have to go for hypothesis testing. Okay, so what we discuss now is how to do how to do this one estimation, okay, when we have a dependent sample. Okay, now we are moving to how to do hypothesis testing when we have a dependent samples. Okay, nothing, just like the ordinary hypothesis testing. Okay, here mu1 and there will be two mu1 and mu2. What is mu1? Average blood pressure level before diet, and mu2 is mean average blood pressure after the diet. Okay, not the cholesterol level, but the average blood pressure after the diet. Okay, so how we can do that things? Someone is missing from there. Okay, no problem, I'll tell you what is that. Okay, so here mu d is equal to mu1 minus mu2. Okay, so our null hypothesis H0 will be equal to mu d is equal to 0 and HA is equal to mu d is greater than 0. Okay, so it means that there is a differences in average cholesterol level or mean cholesterol level after this diet. Alternative hypothesis is that there is no such difference exist. Okay, there is no differences. Okay, then there is differences. Okay, so this would be our null and alternative hypothesis. Clear? Yes. Then the second step is, after specifying the null and alternative hypothesis, we have to use which test we have to use. We have to use t-test. Okay, then third step is determine rejection and non-rejection region. How we can do that? You just check how much confidence level we want. If it is 95%, then you find out what is the confidence interval for alpha by 2 and degrees of freedoms. Using that two values, using the level of significance and DF, you will get the value for table, you will get the rejection and non-rejection regions. Okay, then fourth step is calculate the value of the test statistics. Okay, it is nothing but T is equal to D bar plus or minus mu D divided by standard deviation. Okay, so after that, what you have to do, you have to reject, you have to make a decision whether you have to accept or reject the null hypothesis or not. Okay, so I am not doing these things. Okay, it is if anyone is interested, you can do and you can send me the answer. Okay, then I will see whether it is correct or not. Okay, so the thing is that when the samples are dependent, okay, when the samples are dependent and if we don't know about the population standard deviations, okay, then the sample size is very small, then we can go for paired t-test, okay, or matched t-test or dependent t-test. Okay, so this is what's the procedure of t-test is. Okay, so I hope that this video is helpful for you. If you have any doubts, you can personally contact me. Okay, thank you.